Hello, it's me here. In this video, I'm going to explain what evidence do we have for the Big Bang Theory. If you enjoy this video, then please subscribe and also watch my other videos where I talk about space and physics. I'm guessing that most of you already know what the Big Bang Theory is. But just in case you don't, I will give you a short recap. According to the Big Bang Theory, our universe began from an extremely hot and dense state, much smaller than a proton, and then rapidly expanded. As the universe expanded, it would have looked like an enormous fireball. Under such conditions, protons and neutrons combine to form atomic nuclei. These nuclei then capture electrons to form atoms. Scientists believe that the first element that formed in this way was hydrogen, and the second element was helium. The Big Bang Theory predicts that the first objects to form after the formation of hydrogen and helium were small stars. All we need to do is use Einstein's general theory of relativity and the observed rate of expansion of the universe. And if the Big Bang Theory is correct, then all the helium-4 that we observe today should have been created in the first few minutes of the universe. Those are 7 pieces of evidence that support the Big Bang Theory. If you have ever wondered how does science know what happened in the first few minutes of the universe, then you should definitely watch my video on nucleosynthesis. This is because all the helium-4 that exists today would have been created by the fusion of 2 protons into deuterium and then adding 2 more protons and 2 neutrons. Because protons and neutrons were in such high concentrations in the first few minutes of the universe, this fusion process would have been very efficient. However, once the universe expanded and cooled, the concentration of protons and neutrons would have decreased and thus the production of helium-4 would have slowed down considerably. To make things even more remarkable, the abundance of helium-4 that we observe fits perfectly with the predictions of the Big Bang Theory if we assume that the universe was not created with any helium in it. This is strong evidence that the Big Bang Theory is correct. We can then work backwards to find out how old the universe is. The current best estimate for the age of the universe is about 13.8 billion years. This is in good agreement with the ages of the oldest stars that we have found. If the Big Bang Theory was incorrect and the universe had an infinite age, then the oldest stars should have formed at the same time. Yet we observe that the oldest stars formed over a period of hundreds of millions of years. This wouldn't happen if the universe had an infinite age. These stars would have been very hot and dense and would have collapsed under their own gravity to form either black holes or neutron stars. Evidence for this can be seen by looking at some of the stars in globular clusters. Globular clusters are tightly bound groups of stars that orbit around a galaxy. There are hundreds of these clusters in the Milky Way. And although they contain only a small percentage of the total mass of a galaxy, they contain a surprisingly large number of stars. Astronomers believe that these clusters are among the oldest star systems in the universe. By studying these ancient stars, astronomers have found some stars that have masses several times larger than the Sun but have radii that are much smaller than the Sun. These stars are called blue stragglers. They are extremely hot and would have formed from the remnants of 2 stars that merged. Such mergers would have only been possible in a young hot plasma like the one that existed immediately after the Big Bang. Later, as the universe expands and cools, such mergers would become increasingly unlikely. The existence of blue stragglers strongly suggests that the Big Bang Theory is correct and that globular clusters really are some of the oldest star systems in the universe. We can actually calculate the amount of hydrogen and helium that should exist in the universe based on the Big Bang Theory. And the amounts that we have calculated match very well with the amounts that we observe in space. Scientists have also searched for other elements that may have formed in the early stages of the universe, such as lithium, but haven't found enough of it to confirm that it formed at that time. After about 400,000 years, the universe had expanded enough and cooled sufficiently for electrons to combine with atomic nuclei to form neutral atoms. Before this, photons would have been constantly scattered by free electrons, so they couldn't travel far before getting absorbed. But after the formation of neutral atoms, photons could travel freely. This would have caused the photons in the fireball to suddenly become much less energetic as they no longer interacted with matter. Photons that were once part of the fireball are still around today, and we can detect them as the cosmic microwave background radiation. This radiation fills the entire sky, coming from every direction. Its temperature is about 2.7 Kelvin, which is about 2.7 degrees Celsius or about 48 degrees Fahrenheit. The cosmic microwave background is the oldest electromagnetic radiation we have ever detected and is the strongest evidence we have that the Big Bang Theory is correct. The first observation that led us to conclude that the universe must be expanding was made by Edwin Hubble in 1929. He noticed that all distant galaxies are moving away from us, and the farther away they are, the faster they are moving. This means that all points in space were initially very close to each other and that as the universe expanded, these points would have been carried along and thus all points in space would remain equally dense. However, we do not observe a uniform distribution of galaxies throughout space. Instead, we see that galaxies tend to be grouped together in clusters and superclusters. The largest of these structures is known as the cosmic web. The best explanation for the large-scale structure of the universe is that there were small variations in the density of matter in the very early universe. These variations could have been caused by quantum fluctuations in the otherwise uniform distribution of matter. These small variations in density would have led to slightly higher regions of space having slightly more matter than others. This additional matter would have caused these regions to have slightly stronger gravity. As a result, these regions would attract even more matter and grow in size over time. This process would have continued until the present day, leading to the formation of the cosmic web. Computer simulations of this process show that it is able to recreate the cosmic web if we use the same initial conditions that we use for the cosmic microwave background. Imagine you're looking at two galaxies, one relatively close and the other very far away. Now if we observe the light from both of them, we will notice that the light from the faraway galaxy is redshifted. That means that the wavelength of the light has increased and the frequency has decreased. This happens due to the Doppler effect. You are probably familiar with this if you have ever heard the siren of an ambulance when it passes by you. As the ambulance approaches, the sound waves compress and the frequency of the sound waves increases, making the siren sound higher pitched. Then once the ambulance passes and moves away, the sound waves expand and the frequency decreases, making the sound lower pitched. The same thing happens with light, except that we cannot hear the light. The red shift or blue shift of light tells us if the object emitting that light is approaching us or receding away from us. So if the light from a galaxy is redshifted, it means that the galaxy is moving away from us. Hubble found out that all galaxies are redshifted, meaning all of them are receding away from us. At first, astronomers thought that this was because the galaxies were like planets orbiting a star and that maybe our galaxy is at the center of the universe. However, this doesn't make sense because if our galaxy is at the center, then why would everything be expanding outwards? It would make more sense if everything was expanding together. And that is when it hit scientists. Maybe the universe itself is expanding. If the universe is expanding, then as time goes by, new galaxies would appear at the edge of the observable universe. And indeed, new galaxies are discovered all the time. In fact, we can even calculate how fast the universe is expanding by looking at the redshift of distant galaxies. Today, we know that the rate of expansion is not constant and it's speeding up over time, which brings us to the next point. As the universe expanded, it cooled down and matter condensed into various particles and then combined to form atoms, mostly hydrogen and helium. Stars and galaxies formed from these atoms later on. This theory also explains why the universe is expanding today since it began from a state of high density and low volume. And if the expansion is happening everywhere, then the entire universe is expanding. However, there are several pieces of evidence that support this model more than any other model out there. Let's see what they are. Number 1, redshift. Number 2, cosmic microwave background. When the universe began, everything was incredibly hot. Number 3, abundance of light elements. According to the Big Bang Theory, the universe began at extremely high temperatures and densities. Number 4, large-scale structure. The Big Bang Theory predicts that the universe began from a small, hot, dense point. Number 5, existence of black holes and neutron stars. Number 6, age of the universe. The Big Bang Theory allows us to calculate the age of the universe. Number 7, abundance of helium-4. Helium-4 is one of the most abundant elements in the universe. However, it's only produced in stars. So there you go. Thank you very much for watching and I'll see you next time.